All right, hello class. This is Math 1430, section 3.1, and today's date is August 30th. So today we're just going to find some derivatives using the shortcut rules. So in this chapter, we do not have to find derivatives by that limit definition. Only use the limit definition if they ask you specifically to do it by the limit definition. Otherwise, we'll find derivatives by the shortcut rules, which will make life easier. And either way, you would get the same answer. These shortcuts are theorems. They're proven true. They're proven true. Okay, and again, you would get the same answer if you did the limit definition. It's just that this shortcut rule is much quicker, so why not? Okay, so for the first example, find the derivative for the function f of x equals the cube root of x squared. The first thing I want to do is get rid of the radicals. So whenever you want to use shortcuts, you want to get rid of radicals. So rewrite this as the base is x, the power's up high, and the root is your denominator. So this is going to be the same thing as x to the 2 over 3. So x to the 2/3 power. So that's how you convert radical form to rational exponent form. The power's up high, the root is your index. If there was nothing in this index, that would be a 2 then. Square root means the index is 2. Okay, so now that I have f of x as a power of x, to find the derivative f prime of x, and whenever you're doing a derivative, make sure you denote it. In this case, f prime of x. And this means here comes my derivative. And I'm going to use what's called the power rule. The power rule. And here's how the power rule works. You bring down the power. So I'm going to start off by writing 2/3 times x. And then the power gets decreased by 1. So I got to figure out, I'll do some scrap work here. What is 2/3 minus 1? Another name for 1 is 3 over 3 to get a common denominator. So 2/3 minus 3/3 is a negative 1/3. So negative 1/3. So that's how the power rule works. You bring down the power in front of your base, and then you subtract the power by 1. And then if you want to simplify this, because sometimes the directions might say no negative exponents. So remember, this x is on top with the 2, because it's like over 1. So to simplify, I'll keep my numerator as 2, and then my denominator joining the 3 on the bottom. When I bring the x downstairs, that will make the exponent positive. So x to the positive 1/3 power. That's a 1/3 power, hard to read, sorry. So I got 2 over 3x to the 1/3 power. And if you want to, you can rewrite it as just simply 2 over 3 times 1/3 power means cube root of x. Cube root of x. Remember, the denominator is your index, your root. The numerator is 1, so you don't have to write power of 1. So that's my final answer. Since the original question used radicals, it doesn't hurt to return to radicals in your final answer. So there is my first answer. This will be the derivative of the given function. Derivatives are powerful. They're instantaneous rates of change. They're slopes of tangent lines. They mean pretty much the same thing. The slope of a tangent line means the instantaneous rate of change. And they mean the same thing, and they are found by finding the derivative. Derivatives give us that information for any x in the domain. So for any x, I can find the slope of the tangent line of this original function's graph at any x in the domain, which is the same thing as saying the instantaneous rate of change. Okay, let's go to our next problem. If f of x is given as this polynomial function, we want to find the derivative f prime of x. So let's find the derivative. So if you're going to find the derivative, you must write, your derivative notation. So since this function is given as f of x, write the derivative as f prime of x. Had the function been given as y equals something, then I would write the derivative as y prime equals. Or another name for y prime is dy dx. So those are the popular notations to denote derivatives. So if your function is just given as y, then write the derivative as either y prime or dy dx. They mean exactly the same thing, meaning the derivative function. But if you're given f of x, the best way to write the derivative is just f prime of x. Okay, so here we go. I'm going to use the power rule. So I'm going to bring down the 3. And if you have a number in front, then you just multiply by that number in front. So when I bring down the 3, it's going to be 3 times 3, which is 9. And then you keep your base x, and then decrease the power by 1. So 9x squared. Minus, bring down the power because we're doing a derivative. So multiply this 2 by the number in front. 2 times 2 is 4. X. And then decrease the power by 1. 2 minus 1 is 1. 4x to the first. You really don't have to write the exponent of 1. It looks better if you don't. It just means 4x. So just write minus 4x. Plus, this is like a 1, x to the first. When I bring down the 1, I'm going to be left with 1 times x, which is just x. But then you decrease the power by 1. So the original exponent was 1. 1 minus 1 is 0. So what is 1x to the 0? Well, x to the 0 is 1. 1 times 1 is just 1. So just write 1. In general, if you want to find the derivative of x, the answer is just 1. What's the derivative of 3x? It would just be 3. So the derivative of some number in front of x is going to be that number. So the number in front of this x is just 1. Or you could do it the long way, where the way I was kind of explaining it. You bring down the 1, 1 times x to the 0. Anything to the 0 power is 1. So ultimately you get 1. And then what is the derivative of any constant, any number? The answer is 0. The way to think about that is think of 2 as 2x to the 0, because x to the 0 is 1. When I bring down the 0, 0 times 2 is 0. So the quick way to remember is the derivative of any constant, meaning a number, is always 0. Because derivatives give you slopes. The derivative of a constant function is horizontal. The slope of any horizontal line is 0. Okay, so that's it. This is my final answer. I'm done with that problem. This is the derivative function. A common mistake is just to bring down the equal sign without writing f prime. If you make that mistake, you're saying f of x is equal to this, which is equal to this, and that's not right. You got to write the derivative, f prime of x is equal to this. And then sometimes they might ask you, find f prime of x, and then they might say, find f prime of 2. I'll just do that for fun. Let me do some bells and whistles here. So here's part B of this same problem. Find f prime of some number that's in the domain. I'll say x equals, 2, we'll say. So if I want to find f prime of 2, you first find f prime of x. This will tell me the slope of the tangent line of this graph for any x. But how about the particular x of 2? So let's find f prime of 2. Wherever you see x's, you're going to write 2. This will tell me the slope of the tangent line of the graph of this function when x is 2. So f prime of 2 is going to be, wherever I see x's, I write 2's. So what is 2 squared? It's just 4. Minus 4 times the 2 plus 1. And that's going to equal what? 9 times 4 is 36. 36 minus 8 is 28. 28 plus 1 is 29. So that's a pretty steep slope. And it's because this is a cubic function, which rises quickly. So when x is 2, the slope of that tangent line will be 29. The rise over the run is slope. Okay, and now here's our last problem. Find the slope of the tangent line for this function, f of x equals x cubed, at the point 327, 3 comma 27. Notice when x is 3, f of 3 is 27. 3 cubed is 27. So this point is on the graph of this function. Here's a real quick sketch of this graph. So there's the graph of y equals x cubed. When x is 3, well, we'll say x is 3 over here. When x is 3, y is 27. So what is the slope of the tangent line? So we're looking at, look how steep this tangent line. A tangent line hits the curve exactly once at that point of tangency. Sorry, this is a little sloppy. So I can tell you right now, because this is an uphill line, the slope is going to be positive. Because it's very steep, it's going to be a bigger number. It's not going to be 1 or 2. It's going to be bigger. So the slope of the tangent line is what we want to do. So whenever you want to find the slope of a tangent line, that means you want to find f prime of x, because the derivative will tell you the slope of the tangent line for any x. So let's do that. I'm going to write f prime of x equals, by the power rule, you bring down the power and then decrease it by 1. So this becomes 3x squared. And now this will tell me the slope of the tangent line for any x of this curve y equals x cubed. So how about when x is 3? So when they give you a point, it's the first number, that's your x. And as you know, the second number is your y coordinate. So let's find f prime of 3 and then we'll be done. This will tell me the slope of the tangent line when x is 3. So it's going to be 3 times, wherever you see an x, you write a 3. That 3 gets squared. So that's going to equal 3 times 9. 3 squared is 9. 3 times 9 is 27. And that seems reasonable. That's the slope of the tangent line, a positive 27. Okay, so that is all for today. Don't forget to go to Learn to get the full lesson plan. And, test number 1, I believe, is coming up. Don't forget to look at that syllabus. That's your compass. The syllabus, the best way to find that is math.unm.edu/KevinB. So that will tell you what we're doing week to week. So look for when test number 1 is and what topics it covers. And that will be taken on WebAssign. And I'll give you more information about that later. All right. Have a good one, everyone. Bye-bye.